Okay, so here we have a graph that says the accompanying figure shows the rate at which the transdermal medication is absorbed into the bloodstream of an individual, as well as the rate at which this medication is eliminated from the bloodstream. So what is that telling you about the two graphs? What are they? They're derivatives because this is a rate. So both rates are in units of micrograms per hour and are displayed over this 8-hour period of time. Okay, and then this is micrograms. This is really important. So what does the area between the two curves over time, which is 0 to 8, represent? Gabe.
That integral represents the total amount of blood absorbed into the bloodstream over the 8-hour period.
The total amount of blood? Yeah, okay. If your blood is absorbing blood. Okay, that's okay. So the area between the two curves represents what again?
The total amount of medication absorbed into the blood over the 8-hour period. So
the total amount absorbed? Because this is what's being absorbed and this is what's being eliminated. So what is this right here?
The amount that's being absorbed without being...
The amount that's in your blood. So what's happening is you're being medicated, okay? So you have an IV, let's say, okay? And it's being put into your blood, or if they just give you a shot of morphine, whatever it is, and this is what they give you. This is what's being absorbed, but then your body's eliminating it. So what's happening is as the amount of medication, whatever they give you in terms of micrograms, it's one set amount, right? Your body's going to absorb, and then whatever is not being used is being eliminated. So at the end of 8 hours, it's showing you how much is left in your blood. Does that make sense? Okay, because the area, if this is a rate and this is a rate, the area between the two curves, which would be the integral, is the amount of medication, what's left in there. So here, the area between the two curves represents the amount of medication and they were very specific about it. It's in micrograms per hour. You need to use that somewhere in your answer. This is just for future so that you guys know. Okay, when they give you a unit of measurement, you need to use it in your answer. They're going to want to see it. And when I say they, I'm talking about the people who are reading your answer. So the amount of medication they gave it as micrograms per hour. Whoa. In the body from time 0 to 8. The justification for our answer is the integral. If we called this the absorption minus the elimination. So if we think about this in terms of what we learned last class, it's top minus bottom. Yes?
Why is the unit of the medication in the bloodstream micrograms per hour and not micrograms?
Did I say micrograms per hour?
Yeah.
It's the amount, should be in micrograms. So the area between the two curves represents the amount of medication in micrograms. Thank you. Because that's the amount of medication. Per hour would be the rate. Thank you. In the body over that time interval of 0 to 8. So then you have the absorption minus the elimination. The area between these two curves is equal to the amount left in the body. Because you're integrating. Okay, so why did I ask you to do this question? 2 reasons. Number 1, it's interpretation. We did the car racing problem before you guys left last class. So what was that, Wednesday? And then we were dealing with one form of how we can find the area between the two curves. So we talked about with respect to x, where your functions are in terms of x, your integral will be in terms of dx, and now we're actually going to switch the roles of x and y. So this is really important that you understand the difference. So when we were dealing with respect to x, it was top minus bottom from left to right. Now everything's going to change. It's going to be right minus left from bottom to top. Okay, because it will be with respect to or perpendicular to y. Okay, so you're going in this direction versus perpendicular to x, which was this direction. So when we're reversing the roles of x and y, one thing you need to keep in mind is that sometimes it's much easier to find the area of the region by integrating with respect to y rather than x. And it does depend on your graph. And I did talk to you about this. I think we had a graph where we had to find, there was a region R and a region S, and one of them was clearly a right minus left. So you won't be able to find a top minus bottom. So what we have and what we need to do is make sure that we change, okay, y of x, which is what we had before, to x of y. Okay, so we're going to have y equals something. This is our equation that we would be using, and it's going to go to x equals something. So we're going to have to switch x and y and solve for y. Or excuse me, we're going to have to solve for x. We don't have to switch anything. I was thinking of the inverse. So the second way we can find the area is supposing we have to use totally different variables now. So this is the second way that we can find the area. We have w and v are continuous functions over the interval from c to d. So what they're saying is you have some function to the right of another function. So this is on the right, and this is on the left, whereas before it was top minus bottom. So if we're taking the right side minus the left side, okay, we have to have our bounds from the bottom to the top. Okay, and look at this right here. This is our y-axis, so our numbers run from bottom to top. Okay, so you need to make sure you pay attention to this. So what this means is that we're going to have some curve, x is equal to w of y, that will lie to the right of a given curve. X is equal to v of y. This one is on the left. And the two can touch, but they can't cross. So this is very similar to what we just did already. And if we want to find the area A of the region bounded on the left by this function and bounded on the right by this function, and then we have above and below by y is equal to d and y is equal to c, we're going to have the following formula. So this is what you need to keep in mind. If it's with respect to x, your function is going to be in the form of dx. If it's with respect to y, your function is going to be in terms of dy. You're integrating with respect to y. It's really important. Okay, because we might ask you to show the setup and not even do the problem at all, and we're looking to see if you understand the difference between the two. Okay, so that's even better because that's just a bonus. You don't even have to solve. So here's our area formula. We have our area bounded on the left by this one function and bounded on the right by our other function, below by this line and above by this line. So the area formula looks very similar. The only difference now is we have dy here. Okay, so we have the area is the integral from bottom to top. Okay, we have our height, which is the right minus the left. Okay, and this represents our height. So remember, this took us all the way back to the concept of Riemann sum. Okay, and this dy, even though it gets in significantly smaller, is going to represent our width. So when you're dealing with respect to y, the pattern is right function minus left, and your bounds are going to be from bottom to top. All right, so this is what we had before. These are your bounds. This is your right function. This is your left function. This is why you have to graph it sometimes too. You got to see what's going on because you might not know. And we're looking for the area in between. Okay, so you need to make sure that when you are doing this, that you are reading very clearly what you should be doing.